Section 12.5 is on conditional probability. We're going to learn conditional probability, product rule for probabilities, independent events, applications of conditional probability. So let's start off with conditional probability. It says in the preceding section we discussed the effectiveness of a flu vaccination in preventing the onset of the flu. The table from the discussion is shown below. Here's that table right here that we saw from the previous section. It says, from the table we can calculate the probability that one person randomly selected from this population will contact the flu. So what we did was we looked at the total who contacted the flu, and then we looked at the total number of people that there were in the survey. So remember, it's what you want, in this case those who had the flu, over the total possible, which is the 490. So that gives us our approximation right here of 0.198 when you do 97 divided by 90. 0.198 if we wrote it as a decimal, or we could have left it as a fraction, or even written it as a percentage. So now we're going to change it up a little bit to make it a conditional probability. So what's the key to the word for a conditional probability? What you're looking for is the word given. Anytime you see the word given, we're talking about a conditional probability. What given does is it changes the total set, the denominator. Anytime you see the word given, you're no longer considering the entire set, you are only considering the people in which they are talking about. So you're going to change the denominator of the set. So let's see at this. It says, now consider a slightly different situation. We could ask, what is the probability that a person randomly selected, chosen from the population, will contract the flu, given that the person received the flu vaccination? So what we have to do is look at look at the given information. So here's the given information, given that the person received the flu vaccination. So the only people that we're considering in this chart now is the row of those who were given the vaccination. This is the given information, so this is the only part of the chart we look at. So now it says, what's the probability that the person contacted the flu? Well, there was 21 of those who got the flu, and now the new total that we care about is only the 219. So we've changed what part of the chart we're looking at. We're no longer looking at the whole chart. So again, the way that they're going to write it when you look at it here is they're going to write probability that they got the flu, F, given V, meaning given that they had the vaccination. So again, all this did was changed what part of the chart that we're looking at. We have 21 in our numerator and 219 in our denominator now, which is approximately 0.096. So that's what a conditional probability is. The official notation is the probability using the P symbol, and then they use the B in the vertical line, which means such that, or given. So what's the probability of B given A? Well, it's the probability of A and B over the probability of A. In other words, what I want you to do is don't look at the entire set. Only consider what's given. And then beyond that, this will change your denominator, which was the total. Because remember, it's always what you want over the total. So I don't want you to freak out about this formula right here, probability in A and B over probability of A. I just want you to think that you are not looking at the entire set, you're only looking at what's given. And you got to remember that you're going to be changing your denominator. So let's go to some examples on the next page.